Hey guys, it is Wednesday, April 29th, and last off we were on mountains and we were left with a question. And the question was, wait, whoops, let me share my screen, hold on. And the question was, oh no, we're gonna have to get back into it. So, well, mountain lasts forever. We were on mystery 3, and that was the big question. But we left off on this question. Has anyone ever told you not to put a can of soda in a freezer? Why do you think people say this? And um, I told you, hey, try it out. I said, hey, don't try it out. Sorry, I just got distracted. I was timing myself, making sure the video is not too long. I said, hey, don't try it out. If you have done it before, then you know what it does. And we just got done talking about ice wedging and root wedging. So when it root wedges, it breaks the concrete up. A seed gets inside a little crack, and then it makes the crack even bigger and bigger over time. And ice can do the same thing. But something special happens when that water gets in there and then it freezes as ice. Well, what happens is that it expands and gets bigger. How does this happen? Well, for some reason, ice, when it turns water, when it becomes a solid, which is ice, it gets bigger and expands. You probably can tell because whenever you have like an ice cube tray and you put ice cubes in it, if you really look closely, then the ice will be a little bit bigger than when you filled it up. Also, you have to crack it like this and then pop it out in order for you to get to it. Because it's more wedged in there a lot more. So if you put a can of soda in the freezer, then it's gonna most likely it's gonna bust, but it'll definitely expand. And expand means get bigger. Let me share my computer sound with you. Start this over. Oh, Goose wants to say hello. Hello, everyone. Goose likes to be pet.
Most things, when they get cold, they actually contract or get smaller. But water is weird. Water expands or gets bigger when it freezes. And soda is mostly water. So when you put a can of soda in the freezer, the liquid inside freezes and gets bigger until it splits the can open like this. It can even explode, like this one. If your soda's in a glass bottle instead of a can, that's even worse. You don't want glass flying everywhere. So don't put cans or bottles in the freezer. That's why you hear that. But what does this have to do with rocks? I bet you can guess. As rainwater freezes in the crack of a rocky surface, the water expands, which pushes the rock apart. Crack. We call this, you want to guess? Ice wedging, because the ice wedges itself into the cracks and widens them, just like plant roots. So both root wedging and ice wedging can split a big rock into smaller rocks. Ice wedging is even more powerful than root wedging. The cracks get deeper and wider even more quickly with ice. Look at this. Here's a rock that has been broken up because of ice wedging. You see all the cracks? Here's another one. And look, this used to be just one rock, but it got broken down into smaller rocks, into individual pieces. Ice wedging and root wedging break rock down into smaller pieces. If you walk around at the top of a mountain, you might expect to see only solid rock. But think about it. On the top of the highest mountains, it's often cold, right? Rainwater will freeze. In summer, it might melt, but in winter, it will freeze again. And after all that freezing and melting, the top of a mountain will start to look like this. The surface of the mountain becomes a bunch of smaller, broken up rocks, not all one solid piece. Here's another example of a mountaintop. You see how jagged and cracked all the rocks are? So what do you think? Will a mountain last forever? Well, look at this. This isn't quite as tall as a mountain, but it's still a giant rocky hill. Look at all those splits and cracks. In a few more centuries, as more roots take hold and more water freezes in the cracks, this whole hill will probably split and fall apart into the sea. So we've solved the mystery. Mountains don't last forever. Root wedging and ice wedging breaks them apart. Soon, we're going to do the activity. I want to get you thinking about what happens to the rocks next. You see, once rocks break away from a solid mountain, that's just the beginning of their story. Some of the rocks will tumble down the entire mountainside. They'll get washed away by rainstorms, rolling farther downhill. Maybe they'll fall into a river where they'll get tumbled along, crashing against other rocks. On this long journey, do the rocks get changed in any way? How could we investigate? How could we find out? What happens to a rock once it's broken away from the mountain and now begins to tumble downhill? Try to think of some experiments you could do to figure out the answer to that question.
So, can you think of some experiments you could do to figure out what happens to a rock as it tumbles downhill? I know you don't have a lot to work with and you're tired of your siblings, but please, whatever you do, don't push your siblings down the stairs to see if they'll break, because they will, and that's definitely not what you should do. Also, there is an experiment that we can do, but I don't know if we have the materials because, again, we've been at home and we want to stay at home as much as possible and try and stay safe so nobody gets sick or transmits anything. But the experiment Doug's going to talk about, well, I'll let Doug explain it.
In this activity, you're going to use sugar cubes in an experiment to see what happens as rocks tumble down a mountain. Let me explain. In your class discussion, you did something that scientists do all the time. You talked about how you can experiment to figure something out. How could you figure out what happens to a rock when it tumbles downhill? What are some things you could do? Maybe you thought about comparing the rocks that you find up here to the ones that you find down here after they roll down. That would let you see if the rocks at the bottom were different from the ones at the top. But it would be nice to see what actually happens as the rocks are rolling down. Well then, maybe you could experiment by rolling real rocks down the side of a mountain, like this. That looks like fun. It would be a lot of work. You'd have to find a mountain, you'd have to climb to the top, and it might be dangerous for anyone down below. This doesn't seem like the greatest idea. So maybe you thought about putting rocks in a can and then shaking them so that they bounce around, just like rocks rolling downhill. That's a great idea. We'll do something like that in class today. Except instead of using real rocks, we're going to use these, sugar cubes. Sugar cubes are hard like rocks, and they have sharp corners and edges, just like the rocks you'd find at the top of a mountain. So we'll see what happens to them after a little bit of shaking, and then after a whole lot of shaking. Are you ready to start the activity? I'm going to show you what to do step by step.
Okay, so I do not have sugar cubes in my home, and I don't have a can with me like that. But we're going to skip right through and we're going to talk about it and we can discuss, and you can use your brain and imagine what would happen. And I'm sure you will be able to figure out what would happen. So you would find a partner, etc., and then you would shake it up and you want to see how much of the sugar cube is going to be breaking apart and if it is. So rocks at the top of mountains are jagged like this, and then rocks at the bottom are more rounded like this. Why do you think rocks look different and what happened? So one thing is that, of course, at the top of the mountain, these rocks, they're breaking up a lot. And you have to remember, at the top of the mountain, when you drive through mountains like in McDowell County and Avery County and Burke and Buncombe and all these counties with these high mountains, especially Avery, what you'll see is that at the peaks of mountains, like it said in the video, it's really cold. And so what happens when it warms up and it cools down a lot? Well, it has ice wedging and it breaks these rocks. And those rocks, they're not very smooth, right? Smooth rocks usually happen because they're small from being broken up a lot, and also because water has been running over them. So the very top of mountains, water is not running over them usually. Water usually turns to ice. So two things is happening. One thing is when they're rolling down the hill, they break up and they become really small. And you can guess that because if you take, even though rocks are really hard, if you take a rock and you're rolling it down the hill really fast and it's hitting other rocks, it's going to break, right? I mean, nothing's really indestructible, so it's going to have to break eventually. So, and then it breaks and breaks and breaks and breaks, and then what happens to all the ice at the top when it gets warm? Well, it melts and then it runs down. And when it runs down, what's it going to run over? All the rocks at the bottom. It's going to smooth it out more and more. And just like when it rains, it's going to go up at the top of the mountain and then it's going to wash down.
Discuss this question as a class.
So instead of having loose sugar cubes, what would you have? You may have, it depends on the kind of rock you have. If you have a sedimentary rock, you may have lots of little bits of pieces of sediments, like sand and gravel and things like that. But if you have like an igneous or metamorphic rock, it may be a little different. Igneous rock may be a lot different, but with sedimentary, you'd have, it look like little different pieces. But igneous and metamorphic, or mainly igneous, it looks mostly all black or all one color. So in that case, it would look mostly the same, but it would still be broken up. And the reason we do sugar cubes is because, of course, sugar cubes are going to break a lot easier. And the can, it's not as hard and it's not as tough as the rocks on the side of a mountain. So we know that if we shook it up in a can, it's not going to do as well as rolling down a mountain. So I really want to show you this video from the Yosemite National Park. It's really long, but it's really, really cool. And I wanted to show you this because this thing is super awesome. Actually, I might show it to you. I'm going to show it to you next time, but I do want to show you. Oh, I do want to show you this right here. So these potholes, they come up because water gets into the concrete, and then I explained this in the last video, but water gets into the concrete and then it freezes and then it breaks the concrete up and then it starts to get loose. And the same thing with things like this. This is the root wedging. A seed used to be here and then it just got so big and it just started breaking up the concrete. But yeah. So anyway. So we are going to end this here, and what I'm going to do is I would like to show you this video next time when we come back, and I'm going to read this to you also. Okay? All right, well, it was nice seeing you guys. Let me get off this. Okay? Well, see you guys next time. See you tomorrow. Bye.